A pleasant day to everyone. I am Elizabeth Dueñas, your reporter for today. And for today's lesson, we will be focusing on gravimetric analysis. So at the end of the lesson, you will be able to determine the general steps in gravimetric analysis and learn the precipitation process which is under gravimetry, understand the drying and ignition process, and lastly, carry off gravimetric calculations and applications. From the previous lesson, we already tackled the stoichiometric calculation, and so now we will apply that here in gravimetric analysis calculation. So let's begin. So first, I will give you a trivia. A person you can see in the picture was named Theodore William Richard, who invented or discovered the gravimetric analysis. Along with these graduating students in Harvard, they invented the gravimetric analysis mid-19th century. So basically, gravimetric analysis was first used in United States. So what is gravimetric analysis? It tells here that gravimetric analysis is a technique in analytical chemistry through which the amount of an analyte, or we say the ion being analyzed, or we mean the species of interest, can be determined through measurement of mass. So from the word measurement of mass, it means that gravimetric analysis is an example of quantitative analysis, an analysis through which relating to numbers, or answers the question how much is present in the sample. Gravimetric analysis has 4 different types of method. They are the precipitation, the most common use, volatilization method, electroanalytical, and thermogravimetric method. So first, let us define the precipitation method under gravimetric analysis. Precipitation method is an analytical technique that uses a precipitation reaction, of course, from the word itself, to separate ions from the solutions. What is ions again? So ion is an atom with a net electric charge due to the loss or gain of some or more electrons. Prior to that, the chemical that is added to cause the precipitation is called the precipitant or the precipitating agent. Important notes: precipitation method was used for purifications, removing or recovering salts, for making pigments, to identify substance in qualitative analysis, and also determining the quantity of a substance present in the sample. Okay, so let us move on to volatilization method. In volatilization methods, removal of the analyte involves separation by heating or chemically decomposing a volatile sample at a suitable temperature. So in other words, thermal or chemical energy is used to precipitate a volatile species. Always remember that when we say volatilization method, heating or chemically decomposing is the way to separate or remove the analyte from the sample. Another method of gravimetric analysis was the electroanalytical. So what is electroanalytical? It is a method used to separate and quantify ions of a substance, usually a metal. So when we say electroanalytical, the most common involved element here is metal. In this process, the analyte solution is electrolyzed. What is electrolyzed anyway? So electrolyze is a chemical decomposition produced by passing an electric current through a liquid or solution containing ions. So that's it. Electroanalytical method involves a passing of electric current to separate and quantify ions of a substance. And last but not the least is the thermogravimetric. So thermogravimetric is a technique of thermal analysis in which changes in physical and chemical properties of substances are measured as a characteristic of time. This is commonly used to determine a material's thermal stability and its fraction of volatile components by monitoring the weight change that occurs as a sample is heated at a constant rate. And now I will play a short clip of an analyst performing precipitation method which is under gravimetric analysis. So I encourage you guys to observe carefully and take notes of the important details.
Right, we're going to do a precipitation reaction. We discussed precipitation in the identification of anions, and now I'm going to show you how to do a simple precipitation reaction, which is also a double displacement. So we're going to take one compound here, copper sulfate, lovely blue colored crystals. Copper salts are very, very interesting and colorful, whereas sodium carbonate here, is boring and white, like 100,000 other powders. But when we mix them together, we should have something interesting happen. So I'm going to take a little bit of copper sulfate in a spatula, put it into the test tube, and we're going to add a bit of water to that and dissolve it. So let's just swirl that around until we've dissolved it. It should form a nice blue solution. And while that's busy dissolving, I'll do the sodium carbonate. So we take a little bit of that, we put that into the test tube, and we do exactly the same thing with a little bit of water. And we swirl it around and try to dissolve the sodium carbonate. So we have two solutions here, and what we're going to do is pour both of them through a filter funnel with filter paper in it, and we will get a precipitate, and then we'll get a solution. Here's the filter funnel, and I'll show you how to fold one of these. You take a piece of filter paper like this, you fold it in half, you fold it again into a quarter, so now it's like that, and then you've got something like that. You put that into the filter funnel like this. So, solution of copper sulfate, solution of sodium carbonate. We're now going to combine the two of them. And you can see we've already got a precipitate. There's a solution in there, and there's also something that will not dissolve. And we're now going to pour it through the filter paper, which means the solution stuff will go through, the precipitate will remain. It might take a little while, so we'll come back to it. So basically, the copper sulfate becomes copper carbonate, and the sodium carbonate becomes sodium sulfate. They swap partners, in other words. And this is mostly sodium sulfate at the bottom, and this is copper carbonate, which is a precipitate, which you'll see doesn't dissolve in water, and the filter paper's captured it there very nicely, and it's very blue. So you can see that that's it's even a different kind of blue to the color of copper sulfate. So it's a whole different compound. We call these double displacements. Very cool.
So here are the general steps commonly followed in gravimetric analysis. First is the preparation of solution containing a known weight of the sample. Second is the separation of desired constituent. Constituent means a part of the whole. And third, weighing the isolated constituent. And lastly, the fourth is the computation of the amount of the particular constituent in the sample from the observed weight of the isolated substance. Yes, the last step involves calculation, which is usually a stoichiometry calculation. So for us to be able to carry out the last step of gravimetric analysis, we must study first the stoichiometric calculation. So that's it. If you have any question about the lesson, feel free to ask me. Thank you so much for listening. I hope you learned a lot.